everyone, so for today we'll be working on the solution for week 6 DNA. So in this problem set, what we want to do is to implement a program for DNA profiling where we will examine a DNA sample and match it against the DNA of some individuals to see who it belongs to. So how does this work? So DNA is actually a sequence of molecules called nucleotides arranged in a particular shape which is a double helix. So each nucleotide of DNA contains one of the 4 bases, which is adenine, cytosine, guanine and thymine. So for simplicity, we'll just refer it to as A, C, G and T respectively. So a short tandem repeat, which is STR for short, is actually a short sequence of DNA bases that tends to repeat consecutively at specific locations inside a person's DNA. So the number of times that any particular STR repeats varies a lot between individuals. So for example, for the STR AGT, it is repeated 4 times for Alice, while it repeats 5 times for Bob. So if multiple STRs of a DNA sample matches a person's, there is a very high likelihood that it belongs to him or her. So this is how DNA profiling is done, where we actually compare multiple STRs of the sample against the individual. And if there is a match in the number of multiple STRs, then that is how you know you have matched the DNA to the right person. So this is an illustration of a DNA sample that we have, and let's say we want to look for the STR called AGAT. So within this DNA sample, how many times does AGAT appear? So you can imagine that what we need to do is to run through the whole sample here, and you can see that the number of instances that AGAT appears is highlighted here, and the longest sequence of consecutive AGAT is actually 5 repeats long. So this is essentially what we need to do, where for every STR, what is the longest consecutive sequence? So what does a DNA database that we're given look like? So this is what you see, where the first row gives you an idea of what each row of data contains. So we will have the name, and then the STRs in this case will be AGAT, AATG, and TATC. So the first person in the database is Alice, where the longest consecutive sequence that she has for AGAT is 28, AATG is 42, and TATC is 14. And so on and so forth for Bob and Charlie. So when we are presented a DNA sample, we will actually need to go through it and find out the longest consecutive sequence of each STR and compare it against the database that we have. So if in the sample, the longest consecutive sequence for AGAT is 17, AATG is 22, and TATC is 19, we can actually compare it with the database that we have, and you can see that the DNA sample would belong to Bob. So before we move on, I just want to say thank you so much for watching this video, and I hope that you actually like this video and subscribe to the channel for more videos. Thank you so much for the support. I really appreciate it when someone likes the videos or leaves a comment. So moving on, what is the distribution code that we are given? So this is what we have, and you can see that there are actually 5 sections that we need to work on. Let's understand what each section requires us to do before we dive in. So first, we'll need to check for command line usage, where according to the problem set brief, it states that the first command line argument should be the name of the CSV file containing the STR counts for a list of individuals. So this would be our database. Then, the next command line argument would be the name of the text file containing the DNA sequence that we need to identify. So we are basically identifying the 2 files that we will need to work with in this problem set, where the first one, which is the database, contains the list of people and their STR sequences, while the second one contains the unknown DNA sample, and we will need to find out who it belongs to. So the correct input that we should be expecting would be as such, where the first command line argument would be database. So in this case, we will use large CSV, and then after that, it will be one of the sequences text file that we have. So in the event of the wrong input, so let's say we forget to key in the database file, this will be the error message that should appear. Next, we need to read the database file into a variable. So we'll open the CSV file and read the contents into memory. We can assume that the first row of the CSV file contains the column names. So the first column will be the name, and subsequent column names will be actually the STR sequences as seen below. So now that we have read the database file into memory, now we need to do the same for the DNA sequence file and read it to memory. Next, we need to find out what is the longest consecutive sequence of each STR in the DNA sequence. So for every STR, we actually need to find out the longest run of consecutive repeats in the DNA sequence. So thankfully, we actually have a helper function called longest match that is provided for us, and we'll go through this function later to see how to apply the helper function into the program. So lastly, we actually need to check the database for matching profiles, and now that we know the longest run of consecutive repeats, we will actually compare this against the database of people that we have, and if there's an exact match to anyone in the file, we'll print the name of the individual. If there is no match, we will just print no match. So these are the 5 sections that we need to work on, and we will start with the first 3 sections first. So first, we will check for the command line usage, and basically the system needs to make sure that we key in the database and sequence file names. So you can see that the system should check that we key in the DNA file, and then database file, and then sequence file. So the total number of arguments is 3. So simply put, if the length of arguments represented by len sys_argv does not equal to 3, we can then exit using sys.exit and print this error message to remind the user that there should be 3 arguments in total. Okay? And next, we will actually open the CSV file and read the contents into memory. So according to the CS50 hints given, we can either use csv.reader or csv.digreader, and that the open and read functions may prove useful for reading text files into memory. So let's read the contents into a list that we will call database. So first, we'll need to declare we have a list called database, and then after that, we will open the file. So we will use open sys.argv1, R for read as file. So recall that csv.argv1 will refer to the database CSV file that we've actually keyed in. So we'll use csv.digreader on the file, and as we read the file, we will need to append each row into our list. So when we successfully read the database into memory, and if we were to print the database that we have, this is what you can see we have, where we can see that we have Alice and her respective str counts, followed by Bob and his respective str counts, and so on for Charlie. So do note that each row read from the CSV file is returned as a list of strings. And you can see this in the database file below, where all items that we have read from the file into memory has actually inverted commas to show that it's actually stored as a string. So this is very important because we'll be taking reference to this later. Next, we'll actually open the DNA sequence file and read it into memory. So do note that the DNA sequence file is actually just a string of text. So this is unlike the database file because the database file actually contains multiple rows and columns. But in this case, for the DNA sample that we are working with, it's actually just a string of text. So for this case, we can actually just simplify it and use file.read, which returns the specified number of bytes from the file. So it will be open sys.argv2, which refers to the DNA sample file that we have, R for read, and we'll just use DNA sequence equals to file.read. So let's put all that we've covered so far into the program. So let's work on the first one first, where we'll actually check for command line usage. So if the length of the arguments key in is not equals to 3, we will actually print this error message. We'll use sys.exit for that. Next, we want to read database file into a variable. So we'll declare we have a database, and then after that, we will say we will open sys.argv1 as file, and then after that, we will use csv.digreader. And then after that, for every row that we start to read, we will append it into our database list that we have. Next, we will read the DNA sequence file into a variable. So again, we will use with open sys.argv2 this time, because that will refer to the DNA sample file that we have. And for this case, we will just call it DNA sequence, and we will just use file.read. And yep, that will actually be that for the first 3 sections that we need to do. So moving on, what we need to do is to find the longest match of each str in the DNA sequence. And to help us with this is where the distribution code containing the function called longest match will actually be used. And what this does is it will return the length of the longest run of subsequence in the sequence that we have. So that is, it will actually return what is the longest consecutive run of the strs we are looking for. So let's understand how this function works. So we'll first start by declaring some variables that we will need to refer to. So longest run will actually keep track of the number of repeats of the longest consecutive sequence of the str. Subsequence length actually refers to the length of the str that the system is currently checking, and sequence length refers to the entire length of the DNA sequence that we are checking through. So let's start first, where we'll actually iterate through the DNA sequence using for I in range sequence length. So we'll just iterate through the entire length of the DNA sample that we are given. And we'll use count to track the consecutive runs of a subsequence that we're currently looking at. So what we need to do is that we will need to check for a subsequence match in a substring within the sequence, and we will move down the sequence to check for a match. So this sounds a bit confusing, but I think I have an illustration that will help with this. So in this example that we have, let's say this is the DNA sample that we're looking for. The subsequence that we are looking for, in this case, let's say is AGAT. And since AGAT contains of 4 letters, subsequence length will hence equals to 4. So for this function, this is the formula that we're looking at, and we're looking for a start and end, right? So starting with I equals to 0, remember that count equals to 0 because we have not started counting anything yet. So start equals to I plus count multiplied by subsequence length. So substituting the values that we have, start will be equals to 0 plus 0 times 4 equals to 0. End will be equals to start plus subsequence length. So end will be 0 plus 4 equals to 4. So we have start as 0 and end as 4. So moving on, what the function says that if sequence start to end equals to subsequence, we'll add 1 to the total count, right? So what does this mean? So taking this example here, sequence x colon y actually means get the characters from position x to position y where y is not included. So what this actually means, right, is that putting it back into our starts equals to 0 and end equals to 4, what we're actually doing is that we're checking for the first 4 alphabets here. If sequence 0 to 4, where 4 is not included, that's why I've only highlighted 0, 1, 2, and 3. If it equals to AGAT, this actually means that it matches the current subsequence that we're looking for. If there is a match, we will then add 1 to the total count. If not, we will exit the loop and move on down this chain that we're looking at. So in this case, since subsequence 0 to 4 does not equals to AGAT, we will break out of this loop and move on. So moving on now, I equals to 1. So what does that mean? The value of start will be equals to 1 plus 0 times 4 equals to 1. And the value of end will be 1 plus 4 equals to 5. So since sequence 1 to 5 does not equals to AGAT, we will break out of this loop and move on. Moving on, when I equals to 2, start equals to 2 and end equals to 6. So since sequence 2 to 6 also does not equals to AGAT, we will break out of the loop and move on. So next, when I equals to 3, you can see that the value of start will equals to 3 and end equals to 7. So since sequence 3 to 7 equals to AGAT, there is a match. So we'll actually add 1 to the count. So since there was a match, we'll actually repeat this again. And as I is still equals to 3, start equals to I, which is 3, plus count times subsequence length, where count is now 1. So now start will be equals to 7 and end equals to 11. So sequence 7 to 11 equals to AGAT again, so we'll add another 1 to count. So currently your value of count equals to 2, so that means that you've actually found 2 consecutive repeats of the strAGAT that we're looking for. Now let's test again for the next 4. So now I is still equals to 3 because we are still working on this particular chain. So the value of start now will equals to 11 and end will equals to 15. So in this case, since sequence 11 to 15 does not equals to AGAT, we will actually break out of this loop and move on. So at this stage, the highest number of consecutive runs of AGAT we have is 2. So the max function will then be used in the distribution code to find the largest item between 2 or more parameters. So since longest run currently equals to 0 and count equals to 2, you can see that we will update the value of longest run to 2. So our program will actually continue running through the DNA sample that we have, and as and when it finds longer consecutive runs of AGAT, the value of longest run will then be updated until the program reaches the end of the sequence, and it will then return the value of longest run. So now that we understand how this function actually works, how do we apply this? So at the top of this function, you can see that it states longest match, bracket, sequence, subsequence. So this means that we need to key in the name of the sequence that we are tracking through and the subsequences that we are looking for, and we'll see this in action later. So now, how do we find the longest match of each str in a DNA sequence? Recall that we have a function that returns longest match, and we also have a DNA database file that contains various strs that we need to check the sequence for. So breaking this down into actionable steps, first, we need to store the subsequences into a list. So for example, if we have a list with 3 subsequences, it will be AGAT, AATG, and TATC. We will then need to run through our DNA sequence, which is a sample that we have, and look for the longest consecutive runs of each of the subsequence that we have. So we'll go through the DNA sample that we are looking at, and we will need to find out what is the longest consecutive run of AGAT, AATG, and TATC respectively that we have, and we will store these results in the dictionary. So for example, the dictionary that I will store my results in will be called results, and this is an example of what it will look like. And this is what it will look like. So let's work on each step now. We need to store the subsequences into a list. So recall that for our CSV file, we've actually stored it into database, and it actually looks like this, where the first that we have will be the name, followed by the STRs that we are looking for. So what actually this means, right, is that we need to extract the headers into a list that will look like this, right? So from the database that we're looking for, you can see that the headers we have will be name, AGAT, AATG, and TATC. But at the end of the day, the subsequences list that we want to extract should only contain the STRs that we're looking at. So it will exclude name, and it should contain AGAT, AATG, and TATC. So how do we actually do that? So we can actually use keys, which will actually return the keys of the dictionary as a list. So subsequences equals to database 0.keys. And what will be the output that you get? You will get subsequences underscore keys, name, AGAT, AATG, and TATC. So this is not quite close to what we're looking for, so we need to convert this into a list. So we can update our code now where we actually add list. So if we actually have subsequences equals to list, database 0.keys, this will be the output that you're looking at. Right, so you can see now we've managed to extract the headers of the database file that we have. So now we have name, AGAT, AATG, and TATC. So now we're almost there, but remember, we do not want the word name to be within the list of subsequences. So we actually want the keys from the first variable onwards. So how do we obtain the keys from the first variable onwards? So what we actually need to do is to add this square bracket in with 1 colon. And what actually this does is that it will only take the keys from the first variable onwards. So if we have subsequences equals to list, database 0.keys, and our square bracket 1 colon, this will be the output that we have, subsequences equals to AGAT, AATG, TATC. So this is how you actually extract a list of subsequences from the database that we have. So now that we have our list of subsequences, what we actually want to do is to run through the DNA sequence that we have and find the longest sequence of each subsequence in our list and store the results into a dictionary. So this is an example of what we're looking to extract from the DNA sample that we have. So it will be a dictionary called result, and it will list down the longest consecutive run of each STR. So to do so, we need to iterate through each subsequence that we have extracted, and we'll need to find the longest match for each one. So putting it into code, what we have is that we have a dictionary called result, which is empty for now. And for every subsequence in our list that we call subsequences, we will apply the function that we have called longest match. And for longest match, what we want to do is that we'll be going through DNA sequence to look for the subsequence that we have identified, right? And whenever it returns the longest match for each subsequence, we will actually add it to our result dictionary. Okay? It might sound a bit confusing, but once we put in the code, I believe that it will be easier for us to understand how this flows all together. Okay? So before we put into the program, if you found this explanation to be helpful so far, do remember to like the video and subscribe to the channel. So for the program now, what we want to do is that we want to find the longest match of each STR and DNA sequence. So what we're going to do is that we're going to extract our list of subsequences from the database, and this is done by extracting all the keys in the database except for names, right? So now we declare we have a dictionary called results. So for every subsequence that we've extracted from the subsequences list, what we want to do is that we will apply the longest match function to find out what is the longest consecutive STR count for each subsequence. Okay? And this will be added to the dictionary for each subsequence. And actually that's pretty much that to find the longest match of each STR in DNA sequence. So moving on, what we need to do is to actually check database for matching profiles. So for our last step, what we want to do is to check the database for matching profiles. So what we've gathered so far will be the database of people and their respective STR counts. We also have the list of subsequences that we're looking for. And we also have result, which is the dictionary that contains the STR count from the DNA sample that we have. So recall that for there to be a match, the longest consecutive runs of subsequences for each subsequence must match the individual. So this means that we need to compare each person's subsequence, which is AGAT, AAGT, and TATC, against the results from the DNA sequence, where the STR count of all subsequences must perfectly match the individual for us to use that there's a DNA profile match. So in this case, since the number of subsequences that we have is actually 3, all 3 STR counts of the individual must match for us to determine that the DNA sample belongs to that person. So first what we need to do is to go through each person's STR count in the database. So to do so, we will use the for loop to go through each person. So we'll say for person in database. So in this case, person is the variable that takes the value of the item inside the sequence on each iteration. So for every iteration that we go through, you can see that we'll be going through each person listed in the database. So the first iteration that we'll go through is actually Alice and her respective STR counts. The next iteration will then be going through Bob and his respective STR counts, and so forth. So what we do is that we will access the person first. So first we'll access Alice, and then we will check the STR count, right? And if there's a match between the STR count and the subsequence, we will add 1 to match. So for starters, like I mentioned, we will look through each person in the database. So we'll say for person in database, we start with match equals to 0, as we have not found any STR matches yet. So now that we've accessed the person in the database, we then need to look through each STR and compare each STR count against the DNA samples STR count that we have found that we have put in the result dictionary. So remember that the header of a dictionary is referred to as the key, and to obtain a value from a dictionary, we will use dictionary square bracket key. Okay, and also remember earlier on when we opened the database CSV file and read the contents into memory, each row read from the CSV file is actually returned as a list of strings, right? So if we're actually comparing STR counts, can you see that we're actually comparing the STR counts which are actually numbers? So we need to convert our strings to integers. So putting all this together, right, if we are going through Alice's STR count, int person AGAT will give you 28, right? Because person AGAT will give you the value of the AGAT value that we have. So again, int person ATG will give you 42 and that of TATC will give you 14. So this is how we actually access the value within a dictionary. So likewise, if we're obtaining the STR count for result AGAT will give you 17, result AATG will give you 22, and so on for TATC, which is equals to 19. Okay, so this is what we'll be doing to actually compare the STR count for the person against that of the result. And if there's a match, we will know that this DNA sample belongs to the individual. So how do we put this in code? So previously you saw that I had listed down each subsequence that we have. But instead of listing down each subsequence manually, where we hard code it in, we can actually just do another loop where we loop through every subsequence instead. So putting all this together, it would be for person in database where I loop through each person first, match for now equals to 0, and for every subsequence in the subsequences list, if there is a match between this person's subsequence and that in result, we will add 1 to match. And we will know that there's a perfect match between the person and sample when your total match count equals to the total number of subsequences. Because this means that all the subsequences in your DNA sample matches this person's STR count perfectly, right? So if there's a perfect match, so we'll say if match equals to the length of subsequences, we will print the person's name. But if there's no such match, then we will just print no match. So let's put this in our program. So I just saw that there was an error where our dictionary should be called result instead. So I just edited it. So now for every person in the database, match starts with 0 first. Now we'll look through every subsequence in the subsequences list. So if there's a match between this person's subsequence and that within the result dictionary that we have, we will actually add match plus 1, right? And then if there's a perfect match where all subsequences match that of the person that we're looking at, we will actually print the person's name. And then we'll stop the program. But if there's no match, then we will just print as no match. So let's give this a try. This is a sample that we have. It's Bob. Let's try another one again. So it's Alice. That's correct also. So now let's work on a longer database. So in this case it's serious, and let's try one more where it's to test the no match output, and there you go, it says no match. So let's just apply check 50 on this just to make sure that we have already accounted for all cases that we need to pass. Okay, so you can see that the few tests have passed, and by scrolling through you can see that everything from 1 to 20 passes. And yeah, there you go. So that's actually the solution for problem set 6, which is D and E. Now if you found this problem set walkthrough to be helpful, do remember to like this video and subscribe to the channel. This really helps with the YouTube algorithm, where it will bump up my video for others who are looking for this problem set solution as well. I greatly appreciate it, and thank you so much for your time and support, and I'll see you in the next video.